So now that we've learned what a covalent compound is, kind of how to name them, what our formulas look like, what I'd like to cover now is how to draw out our covalent compounds to kind of give us a picture of what these molecules look like. The molecules that we're going to be drawing, the method that we're using are called Lewis structures, and your book goes through them. I'm going to go through them just slightly different, but the end product is all the same. I do want a huge disclaimer to this video, especially those that are not actually taking my course and are just listening to this video. This is an incredibly basic look at drawing Lewis structures. So if you are required to draw Lewis structures for the course that you are taking, you're definitely going to want to watch a more in-depth video. For this class, for my class online, we just want the very basics of kind of how to draw some really simple molecules. So kind of just some general steps, okay? And they're not really steps, they're just kind of how we're going to go through it. We're going to start with our electron dot symbol, so our Lewis dot symbols, hence Lewis structures. Okay, that's where that name comes from. And then we're going to kind of figure out how we're going to share electrons in order to get an octet. Okay, so how are we going to share the electrons to get 8 electrons around each symbol that we draw? Then once we know which electrons we're going to share and how many, we're going to draw lines to represent each shared pair of electrons. Apparently I can't spell today. Shared electrons. Each line that we draw is going to represent 2 electrons. And again, just like I said at the beginning of the video, these are the very, very basics of drawing structures. All right, so to show these, I'm going to go through a number of examples. And we'll talk about some of the specific things that come up in each of the examples. But what I'd like to do is I want to draw the Lewis structure for chlorine. Remember, chlorine is one of our diatomics. It's one of the exceptions for the naming of our covalent compounds. So chlorine, when I refer to that, is a molecule of chlorine. So there's 2 chlorine atoms in there. Another way that your book could ask this question, because it doesn't always ask specifically for Lewis structures, it could also ask you to draw the electron-dot formula. So I'll show kind of what both of those are. They both are roughly the same. There's not a huge difference between them. All right, so what we want to do is we want to draw the electron dot symbol, okay, for both of our atoms. So we have chlorine. Chlorine is in group 7A, so it has 7 valence electrons. So I have 2, 4, 6, and 7. I'm going to put that unpaired one right next to where I'm going to draw my other chlorine. So I'm drawing these in 2 different colors. Hopefully you can see the difference in the colors. But another way, if you don't have 2 different colors, rather than drawing dots on your second one, you can do X's. So then you can see that there's a different set of electrons there. That also works. I'm going to make mine into kind of dots here. So this chlorine over here has 7 valence electrons. It wants 1. Chlorine here has 7 valence electrons and wants 1 more. So what they're going to do is they're going to mutually share those 2 lone electrons. So that when we write these 2 atoms closer together, this chlorine on the left, okay, it thinks or it feels like it has 8 valence electrons. It has 2, 4, 6, 8. Our chlorine on the right also feels like it has 8 valence electrons. 2, 4, 6, 8. We're essentially double counting one of those electrons. But each of these atoms here feels like it has 8 valence electrons, which is its whole goal in bonding is to get that magic octet number. Except taking away these circles, this would be technically the electron dot formula for the molecule of chlorine. The Lewis structure is a little bit more modern, I would say, but this electron dot does show up in a lot of modern textbooks, so it's not necessarily this is the outdated one, this is the new one. This was more common in older books. Lewis structure is more common in newer books, but they're kind of potato-potato. They're saying the same thing. Okay. So in a Lewis structure, this is where we're going to draw lines to represent our bonds. We have 2 electrons that are shared between the 2 atoms, so we are going to represent those shared electrons as a line. And then we still have those what we call lone pairs of electrons around the chlorine. So, some terminology here. Let's see. I want a different color. These here, and also those and those, and those over there. This is called a lone pair of electrons. Okay. So this chlorine has 3 lone pairs of electrons. So does this chlorine. Okay. It's essentially the electrons that aren't being shared. This line, this represents 2 electrons. And we call this a single bond. So single bond because it's one line. All right, let's look at another example. I want you to draw the Lewis structure for carbon dioxide. So we have to kind of figure out how we want to arrange our atoms. In this example, it was easy. We only had two, so obviously they went side by side. There's no other real option for us. Now that we have two different atoms going on, and actually three total atoms, we have some options. So what we want to do is we want to use that first atom that's listed in the formula. We're going to put that in the center. And then we're going to put the other atoms kind of around that center one. So as a clarification to our rules up here, we want to draw the electron dot symbol, and we're going to put the first element in the formula in the center. The only exception to this is hydrogen. Hydrogen's a bully. It just likes to be at the beginning of the formula. Just ignore it and go to the next element. We'll see an example of that next. So we have CO2, carbon dioxide. So let's put carbon in the center. Carbon is in group 4A. It has 4 valence electrons. So each side of our carbon symbol gets a dot. Oxygen, we'll put kind of on either side of our carbon, try and kind of spread everything out. Oxygen is in group 6A, so it has 6 valence electrons. So we'll have 2 lone pairs and then 2 unpaired up electrons. That'll go for both of our oxygens. Each of them gets 6. This oxygen wants 2 electrons, so does this one. Carbon, kind of as hopefully you can see, has kind of 4 different areas where it can share. So it's going to share all 4 of its electrons. How generous of carbon. So this oxygen is going to share 2 of its electrons with 2 electrons from carbon. This oxygen here is going to share 2 electrons with 2 electrons from oxygen. In the electron dot symbol, or the electron dot formula, we're going to stick the shared electrons right in between our symbols. So oxygen here is sharing 2 electrons, so there's oxygen's 2 electrons it's sharing. Same thing over here. And then the 2 electrons in the center, those are carbons. For each oxygen, we still have the lone pairs. So we have 2 lone pairs on each of the oxygens. The other way that we can do this, okay, is we have 4 total electrons shared. So each line in the Lewis structure represents 2 electrons, so we'll have 2 lines. Or you can look at over here, we have 1 line, 2 lines, 1 line, 2 lines. So we have, don't want to mess up my colors here. Excuse me. So this here, this is called a double bond. And we have 2 lines which have 2 electrons each. So 4 shared electrons in that bond there. Okay. This is also a double bond, so there are 2 double bonds in this molecule. Okay, there's 1 double bond, there's 2 double bonds. Let's look at another example. Draw the Lewis structure for HCN. Just rewrite that. So here's an example. Our first element here is hydrogen. Hydrogen's not in the center. He's just a bully. He likes to be at the front of the formula. So we want to stick carbon again in the center. That's the next element that's listed. Then we'll have hydrogen on one side with its 1 valence electron. And then, oh, that's a little close to blue. Let's do my light purple. We'll put nitrogen. Nitrogen has 5 valence electrons. It's in group 5A. So we have 1, 2, 3, 4, 5. And when you're drawing out your dot symbols to do a Lewis structure, if you stick the lone dots kind of towards the other atoms, that'll make seeing how the bonds form a little easier. So I specifically put these 2 electrons on the outside of that. One of the same things I did kind of up here with the chlorines, I put the single electron on the inside, and then this one single on the inside. So it was easier to show that bond forming. So here, looking at the bonds that are formed, hydrogen and the carbon there, they're going to share those electrons. Hydrogen, again, is okay with just 2 electrons. It doesn't want an octet. It wants to be like helium, which has 2 electrons. So by sharing its 1 electron with one of carbon's, hydrogen gets its 2 electrons. Then we have 3 electrons left on carbon. Okay, so it wants to share all 3 of those. Same thing over here. Nitrogen has 3 electrons that that nitrogen wants to share. So between carbon and nitrogen, they're going to have 6 total electrons being shared. I'll show you the dot symbol for that, and then show you the it's a little weird to do the colors, but that's okay. It works. There's the electron dot having the 6 total electrons in between. Again, Lewis structure, a little bit more common currently. So we have a single bond between carbon and hydrogen, just 2 electrons, so we have 1 line. Then between carbon and nitrogen, we have 2, 4, 6 electrons being shared, where you can see the 6 electrons there. So we draw 3 lines. That's called a triple bond. So we have 3 lines or 6 electrons that are shared. All right, try this example on your own. I want you to draw the Lewis structure for COCl2. So draw the Lewis structure for COCl2. Go ahead and pause the video, and then when you unpause, you can listen to the solution. Really do try these on your own so you can kind of see where your stumbles are and get those corrected before you start attempting the Q&P and the sapling questions. All right, so carbon is listed first, so we're going to stick carbon there. And it has 4 valence electrons, so we have 4 dots. We have oxygen is next, so we'll stick oxygen on one side. Oxygen has 6 valence electrons. Then we have 2 chlorines, so we're just going to draw these chlorines kind of around carbon. So let's stick one down below and one over to the other side, opposite side of that oxygen. Each of these chlorines have 7 valence electrons. So oxygen here has 2 electrons it can share. It's going to share with 2 electrons from carbon. So that'll form a double bond there. Chlorine has 1 to share, so it'll share with carbon. The other chlorine has 1 to share, so it will share with chlorine, or with carbon. Chlorine's going to share with carbon. Carbon's going to share with chlorine. So we have the 2 shared electrons of each between oxygen and carbon, so a total of 4 shared electrons. That represents our double bond. Then we have single bonds to the chlorines. And I forgot lone pairs, so I want to include those on my atoms.